Hi everyone, it's Emily, and today is day 85 of the Odin project. Today I finished up my linked list project for the JavaScript course, and I started the binary search tree project. In yesterday's vlog, I did a walkthrough of all of my code for the linked list project, and this morning I was able to do some more error handling. So I created a helper function called handle error that I'm able to call for any of my methods that depend upon the existence of a linked list, so that if a linked list does not exist, then I'll return a statement saying a linked list does not yet exist. So for example, I use this for my head node method. The head node method is supposed to return the first node in the list. And so I have some logic that if head equals null, which means there isn't a list, then I will call that handle error function. And this just cut down on my code because I was able to just pop this function into the majority of my methods because most of them did depend on having a linked list that already exists. I was able to test all of my methods using the scenario where a linked list would only have one node in it. And I realized that I needed to add some more logic for my pop method. The pop method is supposed to remove the last node from the list. And if the list only contains one node, then my method wasn't actually working properly. And so I added the condition that if length equals 1, then we set head equal to null, which effectively just gets rid of the list. And then we reset our list length to 0. So once I incorporated these changes, I moved on to the next lesson, which is binary search trees. Now, binary search trees are just another way of organizing data, again with nodes. So you can see the nodes create this big tree that's on the left-hand side of the screen. And with binary search trees, the left nodes are supposed to be lower than the right nodes. And specifically, we're working with balanced binary search trees. So you'll see here on the left, this is an unbalanced binary search tree. And then on the right, this is a balanced binary search tree. So a balanced binary search tree is basically where the difference in height between the left-hand side and the right-hand side is no greater than roughly 1. And so even just looking at it, you can just tell if it looks balanced or unbalanced. So for this project, we are tasked with creating functions where we can build binary search trees, and then we are building functions that allow us to manipulate the binary search trees and traverse them to search for specific values. So I created a function which builds binary search trees. I'm not going to do an in-depth review of my code right now because it is still in progress and I might end up reorganizing it. But at this point, you can pass an array into the function and the function will sort the numbers in the array. It will remove any duplicate numbers, and then it will assign the middle element of that array as the root. And then it will basically break the left subarray and the right subarray into two separate parts and recursively call those to continue identifying the middle parts of those subarrays as nodes and then breaking apart the left-hand and the right-hand side subarrays. And that effectively builds the binary search tree. So I'll show you what I'm talking about. I can set the variable example equal to build tree with an array that has a variety of unsorted numbers with some duplicates. And then I'm going to use the pretty print function, which is a function that was provided to us in the instructions for this project to be able to print the binary search tree to our console so that we can see a visual of it. And so if we pass our variable example into it, then we can see, oh look, we have a beautiful little binary search tree here. So tomorrow I'm just going to dive deeper with this project and I'm going to start working on the functions for being able to manipulate the binary search tree. So that is all that I have for today. Thank you so much for tuning in. Be sure to let me know about your own coding journey in the comments below. I'd love to hear if you are completing the Odin project, what you think of it, and where you are in the curriculum. Be sure to hit the like button if you enjoy these updates, and hit the subscribe button if you'd like to follow along on our coding journey. I hope that you have a great day, and I will see you next time.